Population represents all observations of people that we are interested in knowing about, but a sample includes the observations of people that we will actually measure. While a parameter is a measure based on the population, a statistic is measured on the sample and helps us estimate the parameter. We talk about scales of measurement. They are all valuable. Some give us more information than others. Sometimes we might want to classify people into short and tall groups, but we could have so much more information if we knew the height in inches of each person. If we were gathering data on this classroom, I would not write down you're short, you're tall. I would gather the height in inches of everyone, save that information, and then divide them into short and tall if I wanted. I could always go back to the actual height and not be left with only the groupings. When we talk about variables, we're talking about things that can change or vary from one person or event to another. Even if we're not trying to prove that one variable, like frequency of e-cigarette use, causes another variable like frequency of cancer, we would still be interested in identifying a potential independent variable and the dependent variable. The dependent variables are the scores or outcomes that we obtain, while the independent variables are the things that we generally manipulate. In the case of frequency of e-cig use, it would be unethical to ask one group to smoke more than another. That experiment would not be allowed in the current scientific communities. A group at each university called the Institutional Review Board, or Human Subjects Committee, is responsible for looking at all studies and saying which ones are ethical or not, and which ones can proceed. However, if people are already using e-cigarettes, we could compare them to people that are not using. Naturally, the amount of e-cigarette use would be our independent variable, while the occurrence of cancer or frequency of cancer would be our dependent variable. While it's clear that we think one might cause the other, it's important not to make that assertion. Many of our statistical analyses do not prove causality. Rather, a correlation, for instance, shows us that there is a relationship between these two things, but does not specify that one causes the other. We cannot prove causality with the data that we have. However, relationships often point us in the direction of something causing something else, so that we could do an experiment later on and prove causality. I want each of you to write down 5 pairs of independent and dependent variables. Remember that a variable is measurable. You can think about something causing something else, or you can think about two things that are related. Try to make your pairs logical. Think about whether it would be possible to use a random sample to find one, and randomly assign people to a group, or whether you would have to use a convenience or naturally occurring sample. Next, we'll look at measurement, which describes the properties of the numbers that we obtain from the data that we collect. Again, before moving to the next slide, press pause and write down 5 pairs of independent and dependent variables. As we start to think about scales of measurement, I'll give you some examples. When we're in a swimming meet or race of any type, they often give us a number. What meaning does that number have? Probably it just refers to the number in which we showed up to the race, and it allows the judges not to confuse one person with another. If we ask where someone finished in the meet, that would be in order. But would the difference in times between each finishing swimmer be exactly the same? Probably not. How many seconds did it take you to swim a lap? That is an exact time, an exact amount, and gives us different information, a different type of information than what order you placed in your participant number. Nominal scales are categorical scales. The numbers themselves have very little meaning, if any. When taking a survey, I might ask you to place a 1 in the box if you are a male, and 2 if you are a female. Those numbers are only used for classification by gender. In this case, I don't put them in order from best to worst or from lightest skin color to darkest skin color. If I did, it would not be a nominal scale. The other types of scales are called true scales. The numbers mean something. The simplest true scale is an ordinal scale which orders people, objects, or events along some continuum. When we think about what order someone placed in a swimming meet, swimmers are being placed on an ordinal scale. Ordinal scales give no information about the differences between points on the scale. If you were to say that you had 20 stressful events in your life and I only had 10, that wouldn't necessarily mean that you are twice as stressed. My 10 stressors might be much more stressful than your 20. An interval scale is a scale of measurement about which we can speak legitimately of differences between two different scale points. Think about a fever. We're thinking about temperature in that case. A 10-point difference has the same meaning anywhere along the scale from 10 degrees to 20 degrees, or from 8 degrees to 90 degrees. Interval scales do not have an absolute zero. The Fahrenheit scale goes below zero, especially in cold climates, but an absolute zero means the absence of temperature, which does not exist in an interval scale. A ratio scale is slightly different in that it does have a true 0 point. Although the Fahrenheit temperature scale has a 0, that 0 does not refer to an absence of temperature. However, length, volume, weight, all have an absolute 0 and are appropriate ratio scales with the difference between each point on the scale being the exact same amount. With ratio scales, we actually can say something is twice as much or half as much as another value. Few people would say that if I got 100 on an exam and you got a 50, then I know twice as much. We must be careful how we interpret scores that are based on different measurement scales. When we refer to methodology, we are referring to how a study is set up. While we might think that 100 on a ratio scale should allow us to say you're twice as smart as someone making a 50, but the way the test is set up may not be methodologically sound to make that interpretation. Properties of objects or events that can take on different values are referred to as variables. Think about hair color, eye color, height, length, speed. These are all variables. We can discriminate between discrete variables like gender, marital status, or the number of television sets in your home. In these cases, the variable can only take a relatively few possible values. However, with a continuous variable like speed, height, or weight, we see that the variable can assume any value between the lowest and highest points on the scale. The continuum is larger. We also distinguish between independent variables. Those that are manipulated by the experimenter are independent variables. Dependent variables are not under the experimenter's control. They are the result. These are the data. The study is normally about the independent variable, and the results of the study are measurements of the dependent variable. Note that when we use gender as an independent variable, we only have two levels or groupings, unless we were to look at gender as a continuum. We can't randomly assign people to a gender group. Would gender ever be a dependent variable? Random assignment or random sampling allows us to be sure that every score in the population has approximately equal chance of being included in the sample. Why obtain random assignment? I could write numbers on little sheets of paper and have you pull the slips of paper out of a hat and you would be randomly assigned. Or I could put all of your names into an Excel spreadsheet and place a randomly generated list of numbers next to your names. You can find these online easily by typing in random number generators, or you could look at Appendix E, Table E9. The goal is to eliminate as many sources of possible bias as we can, restricting our conclusions with respect to those sources of bias that we cannot feasibly control, and any biases that we cannot control will limit the degree to which the results can be generalized to the population. I'll see you soon to talk about notation.